and welcome to our first physics video. Today we're going to be talking about force and motion, specifically forces and then balanced and unbalanced forces. So the way these videos are going to work, I'm going to have a PowerPoint, I'm going to go through them, I might put some videos in here as well. We'll just go through a normal lecture. Alright, so our essential question, how do forces impact motion? So first off, a force is a push or a pull on an object. Force, we have Newton's first law. Force equals mass times acceleration, which is why we have this very funny picture down here. And then that gets abbreviated to F equals ma. And then the unit is Newton. So the unit for force is newtons, which is abbreviated to a capital N. It has to be capital. It cannot be lowercase. Lowercase n means something else. So I have a question for you. Do you know who the unit of force is named after? Hopefully you realize that it's for Isaac Newton. So gravity is a force. Force is newtons, as in Isaac Newton. And so we have two types of forces. We have a non-contact force and a contact force. Just like a non-contact sport and a contact sport, non-contact is a force on an object by another object that is not touching it. And then a contact force, a force on an object by another object that is touching it. So you can see here, so static electricity there, or static energy when you have the balloon attracting the hair. So that's a non-contact force because the balloon is not touching the hair. And then a contact force. You can see here the guy is breaking those, and he is very much touching those wooden blocks as he breaks them. So try to list 3 non-contact or contact forces that exist. As I go through this video, I'm going to be asking you guys some questions. So if you have a sibling or a parent or a friend around, you can talk to them about it, or if you just want to talk to the screen, that's what I'm doing. So go ahead, list 3 non-contact or contact forces that you think. Like I mentioned, we have Newton's first law of motion. If the net force on an object is 0, the motion of the object does not change. You may have heard this before in other words. An object in motion tends to stay in motion. An object at rest tends to stay at rest, meaning basically if you put a coffee cup on the table, the coffee cup is not going to move until you move it. It is going to stay at rest because an object at rest tends to stay at rest. Or if you were to slide a hockey puck across an ice rink, until it hits the wall, it's going to keep moving. So an object in motion tends to stay in motion. And that is all based on the idea of inertia. So inertia is the tendency of objects to resist a change in motion. Basically meaning if you have more inertia, you're going to resist the change more. Which has more inertia, a mouse or an elephant? What do you think? An elephant has more mass, it's bigger, so it's going to take more to get it going or to get it to stop than a mouse. And so the big thing that we're going to be talking about today is net force. So you may have heard net force before, like net worth. So like how much someone is worth, their total worth. A net sum is basically the total amount with all the additions and the subtractions. So a net force is a combination or sum of all forces acting on an object. Because there might be multiple forces acting on an object, and so you have to take all of them into account. We like to show that with arrows, which we'll see on the next slide here. Arrows represent force. Longer arrows equals more force. And so again, we'll see that on the next slide. But we can have either balanced forces or unbalanced forces. A balanced force has a net force of 0, so it is not moving. So basically either there's no force on it or the forces are canceling each other out, kind of like a game of tug of war. If both sides have equal force, nothing's going to move. So it is balanced. And then we have unbalanced. An unbalanced force is where the net force, or the total amount of forces added up together, is not 0, meaning that there is some force going on, meaning the object is moving. Like I said, there are some arrows involved. We have the net force, which is the total amount of all forces acting on an object. Arrows represent force, longer arrows, more force. So you can see here we have 5 newtons. So capital N, again, is newtons. 5 newtons on this side, 1 newton on this side. And also something you have to pay attention to, along with the amount of force, is the direction of the force. So if this is just a normal box, this arrow represents someone pushing on the box this way. And then this arrow represents someone pulling the box the same way. So those arrows are both going in the same way. So if they're pointing the same way, you want to add them together. What is the net force of the blue box? The blue box has 5 newtons pushing it to the right, and then 1 newton pulling it to the right. So a total of 6 newtons to the right. So when we calculate how much force, how many newtons, we also want to think about the direction. And then for the green box, we have again 5 newtons and 1 newton. This 1 newton is pulling to the right still, but this 5 newtons is pulling to the left. And so if the arrows are pointing different ways, you want to subtract them. It'd be like people trying to cancel out or fight over something. So we have 1 newton going this way, 5 newtons going this way. And so the net force, or the total sum force, would be 4 newtons, and it'd be going to the left because the stronger amount of force, the greater amount of force is going to the left. And so we take 5 newtons and we subtract the 1 going in the opposite direction. But now let's actually think about, are they balanced or are they unbalanced? So do you think that these 2 boxes have balanced or unbalanced forces on them? So they are both unbalanced. Because they have an unequal amount of force on them, meaning that they're actually being moved in a certain direction, it means that they're unbalanced. If they were not moving, then they would be balanced. So let's look at some more examples. So now we still have our blue box and our green box, and now we have 5 newtons pushing it to the right, and for the other side, we have 5 newtons pushing it to the left. So based on our rules up here, what would the total amount of force be, or the net force of the blue box? 5 newtons pushing this way, 5 newtons pushing this way. They're pointing different ways. We subtract them. So 5 minus 5 gets us 0. So it is 0 newtons. There is no force on this, or no net force, total force. We can see the 2 forces, but they cancel out, and so it's balanced, not moving. Then for the green one, we have 1 newton pulling to the left, 1 newton pulling to the right. What would the net or total force of the green box be? Also 0 newtons, because we have 1 minus 1 pointing in different ways. We subtract them, we get 0. Another example we have is that there could be more than just one force on either side. There could be multiple things happening to this box, but we have 5 newtons and 2 newtons pushing this way, and we have 5 newtons and 1 newton pushing that way. So we have a total of 7 newtons pushing to the right, and a total of 6 newtons pushing to the left. What would our net force be on this blue box? 1 newton, because we know 7 minus 6 gets us 1. And it's going to the right because there is more force pushing it to the right. And then would this be a balanced or unbalanced force? Unbalanced, because it is moving. If it's moving, it is unbalanced. We have 5 newtons pushing down and 2 newtons pushing up. What is the net force of this blue box? Hopefully you're getting the hang of this and see that it is 3 newtons pushing down. Because they're pointing different ways, we subtract them. 5 down, 2 up. We have a net total, a net force of 3. The larger one is pushing down, so it's going down. So take a moment, look at these 3 problems, try to figure out. I'm going to just sit here and wait. Look at some answers and see if they make sense. So unbalanced, unbalanced, and balanced. Balanced just means that it's not moving. So we have a balanced act right here. And then we can have multiple forces from multiple different directions, just like before. So take a look at this one. What do you think? What is the net force on this blue box? Going left and right, the 5 newtons here cancels out the 5 newtons over here because 5 minus 5 is 0. So there is no force going left or right, but there is an unequal, or you might call it an unbalanced force going up and down. We have 5 newtons pushing down and still those 2 newtons pushing up. And so the net force is 3 newtons pushing it down. What do you think? So it is unbalanced because we have 8 newtons going up, 4 newtons pushing down, and so we have a total of 4 newtons pushing up. And then this would be an unbalanced system, an unbalanced force. To wrap it up, a force is a push or pull on an object. The unit is newtons. Again, the N has to be capital. Non-contact, a force that is not being touched by it. So like gravity, there's nothing touching us, pushing us down, but gravity is still forcing us. And so it is a non-contact force. Then we have a contact force, where the object is being touched by another object. And then net force, the total combination, sum of all the forces. Balanced, net force is 0, it is not moving. Unbalanced, net force is not 0 and is moving. And then an example of these diagrams. If you have any questions, send me a Schoology message, send me an email, and have a great day. Bye!